Okay, hello everyone. I welcomes to all in our lecture series on fiber optics. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last class, we have been discussed introduction and basic principle of data propagation in fibers. In this class, we are going to discuss acceptance angle and acceptance cone. Okay, so let us start. In the last class, we discussed introduction part of optical fiber. This is the physical appearance of optical fiber, and these are the components. Okay, we discussed in our last class. We discussed the basic principle, which is the total internal reflection of this fiber optics that we discussed in detail. In this class, we are going to discuss acceptance angle and acceptance cone. Here you can see the optical signal propagates through the optical fiber with the principle of total internal reflection here. Okay, from this end of this optical fiber to another end. But here this incident angle is most important. Here this is the incident angle with the optical axis of this optical fiber. This is the optical axis, this is the incident angle, this is the incident angle, this angle. With a particular angle, the light will propagate, or light will happens the internal reflection inside the optical fiber. Otherwise the light could not propagate, or you can say could not total internal reflected inside this optical fiber. This angle, this particular angle, or the maximum angle with which light will travel or total internal reflection happens inside this optical fiber, that is called as the acceptance angle, that we are going to discuss in this class, and we are going to derive what will the value. Okay, so here I considered a ideal fiber. This is the cladding part, outdoor part, having the refractive index n2, core part refractive index n1, both of made up of glass but different refractive indices. This is one face, this is the another face of this fiber, and this is the this dotted line represents the axis of this fiber. Okay, now here from this end we are going to incident with different angle the light signals, and we are going to calculate what will be the maximum angle with this axis that the light will propagate through this optical fiber with internal reflection. Okay, here you can see, suppose I incidents a light signal or ray with an angle, suppose this theta I. Okay, this is the rarer medium having a refractive index n0 as compared with the cladding and core, and this is itself the AR medium. Mostly ideally this is the AR medium. From this medium we are trying to propagate the light signal from this end to another end of this fiber. So here with this angle light incidents, so this core part is the higher refractive index as compared with this medium or n0. So obviously it will bends towards this axis somewhat, then propagated through core part and strikes at the interface of core and cladding. And we know the cladding having the less refractive index than the core. So when it will interact with this interface, the light will transmit or refracted through the cladding by moving away from this normal like this. Okay, so if it is so, we could not get the internal reflection at this point. That means this angle could not be acceptable. This angle could not acceptable. Now we are going to change the angle. We are going to just decrease the incidence angle, this one. Consider this theta I here. With this theta I red line, you just mark the red line. red incident line. So red incident line gone like this, and at this interface again it is refracted through cladding, not internal reflected. That means this angle also not acceptable. This angle also not acceptable. Now I am going to decrease the angle like this. Consider this angle, the black ray, this one. Let this is the angle is your theta 0. With this theta 0 we found at the interface the refracted angle just on the surface of this core. That means we can say with this angle light will propagate through this core. Okay, light can be propagate on the surface of the core or through the core with this angle. If I'm going to decrease the angle, so yes, if it is so, that means this angle will acceptable. This angle is the acceptable angle for this fiber, right? Same thing I have been written in your note. Here you can see, let the refractive index of the core is your n1 and refractive index of the cladding is your n2. Here n2 is less than that of the n1. N naught be the refractive index of the medium from which light is launched into the fiber, this one, this medium. The ray refracted at angle theta r and strikes the core and cladding interface and angle phi. Here this angle is your phi, or you can say this angle also phi. Here I written the ray refracted angle theta r. Theta r means here refracted an angle theta r. This angle, this angle are theta r, and strikes the core and cladding interface. This one, core and cladding interface. This is the core and cladding interface. This is the core and cladding interface at an angle phi. At an angle phi means this angle also phi. So here you can see this phi angle is less than that of the phi c. This phi c is nothing but your critical angle, due to which at this interface, core or cladding and cladding interface, the transmitted ray moved on the surface of this core, and this phi angle, or this phi angle, if we are going to consider, less than phi c, right? So here at an angle or with an angle theta 0, the incident ray starts internal reflection. You can say like this, starts internal reflection. Again, if I'm going to decrease this angle theta naught, then we can get the internal reflection inside the core part. Here you can see I considered another ray having the angle theta I. Here this theta I is less than that of the theta 0. You just mark upon this dotted arrow line, entered into the core, okay, and refracted inside the at this interface A. Again it strikes at point B. Here this angle is greater than that of the phi c. Hence at this interface this ray will fully internal reflected inside this core, like this, fully internal reflected. That means this angle will be this angle. If we are going to consider this angle phi, this angle also will be phi, and here this phi is greater than that of the critical angle phi c. Maybe I have been written also, yes, this phi, this is the angle phi, this is also with the angle phi, and here phi is greater than that of the phi c, and we can get the total internal reflection. Here I do not have the portion of this fiber this side. Here you can see this ray will be again internally reflected at this point, like this, and it will be moved through this core by internally reflected like this. Okay, so here if 1 mark question asked in your exam, define acceptance angle, this much you have to write. Acceptance angle is the maximum angle that an incident ray, this one, incident ray can have relative to the axis of the fiber. This is the axis of the fiber. This is the axis of the fiber. And propagate through the fiber. That means theta 0. So this much you have to write for your 1 mark question. Right. Now we are going to go for calculation of this acceptance angle. Okay. So here for that we considered only these two rays. Here you can see. For this dotted ray, incident angle is your theta I, refracted angle is your theta R. Apply the Snell's law. What we can get? Sin theta I by sin theta R equal to refractive index of this medium by refractive index of this one, this medium. So here the refractive index of this core is your N1 by incident medium is your N0. Let this is your equation number 1. For internal reflection, the largest value of theta I occurs when phi equal to phi c. Whatever already we have been discussed. So here for internal reflection, that means for phi equal to phi c, the internal reflection starts. Right. Now consider this triangle A, B, C triangle. This A, B and C triangle, sin theta R, here you can see this is your right angle triangle. Sin theta R can be written as sin 90 minus phi. This is your phi angle. 90 minus phi can be written as cos phi. Now put this value, equation number 2 value in your equation number 2. Sin theta I by sin theta R, which is equal to cos phi. If I am going to substitute over here, then it will be multiplied with this fact with the right side. Then we can write sin theta I equal to n1 by n0 equal into cos phi. Right. Now when phi equal to phi c, we found theta equal to theta naught here. Theta naught, for theta naught, this phi is nothing but your phi c. So here, if I am going to consider this theta I equal to theta naught, then this phi is nothing but phi c. Same thing it has been written. Sin theta naught will be equal to here n1 by n naught into cos phi c. We have to write cos phi c. Let this is your equation number 3. At point D, here I forgot to write this point is your D. It will better I have to write. Just wait. Here at point D, that means at this point, if I am going to apply the Snell's law, here this is your incident angle and this is your refracted angle, value is your 90 degree. Applying Snell's law, what we can found? Sin phi c by sin 90, incident angle, sine of incident angle sin phi c by sin 90 by equal to n2, this one, n2 by refractive index of n1, this one, n2 by n1, right? Sin 90 value is your 1, that implies sin phi c equal to n2 by n1. If sin phi c equal to n2 by n1, then cos phi c will be equal to how much? n1 square minus n2 square by n1. Here n1 square minus n2 square root over by n1. How it is easily you can found? If I am going to consider sin square phi c, this will be n2 square by n1 square. And cos square phi c will be equal to 1 minus sin square phi c, which will equal to 1 minus n2 square by n1 square, which will be equal to n1 square minus n2 square by n1 square. So if cos square phi c will be this much, then cos phi c will be root over of this one, that means n1 square minus n2 square root over by n1. Then let this is your equation number 4. Now substitute equation number 4 in 3, we can get here. Instead of cos phi c, we have to substitute this value. Okay, if I substitute this value instead of cos phi c, here n1 got cancel, and we can found this one n1 square minus n2 square root over by n0. So by substituting equation number 4 and 4 into 3, we get sin theta c theta 0 equal to this much. Let this is your equation number 5. N naught is the incident medium refractive index. In general, that medium is your air medium. So we can put N naught equal to 1. Now equation number 5 will be here. I have to substitute 1. So sin theta 0 will be equal to n1 square minus n2 square root over. Let this is your equation number 6. That implies theta 0 or the acceptance angle will be sin inverse n1 square minus n2 square root over. Let this is your equation number 7. This is your mathematical value of acceptance angle if both the refractive index has been given. So easily we can find the what will the acceptance angle of that particular fiber, right? Now we are going to go for acceptance cone. Here in 2D picture, this is the angle. This is the angle in the 2D picture. If I am going to consider 3-dimensional picture, here, if this side is your theta 0 acceptance angle, also this side we can consider theta 0, right? And this cone, it will form a cone, right? It will form a cone. That means inside this cone, whatever the light will incident, that will propagate through this fiber. That means whatever the light passed through this cone and incident on this face of this optical fiber, those rays will happens internal reflection inside the core, and the signal will transmit from this end to this end. So in 3 dimension, the light rays contained within the cone having a full angle, how much? This is your theta 0, this is the theta 0, 2 theta 0, are accepted and transmitted along fiber, what I discussed, and this cone is called as your acceptance cone. Okay, so here I am going to stop today's class. In our next class we are going to discuss fractional refractive index change and numerical aperture. Thank you so much for watching this video. Thank you.